Okay, so today's another day that should be pretty easy. And look at me, I'm going to get rid of that right away. I'm getting better. You're going to take some notes on writing chemical equations. So we've already practiced this a little bit. You've learned about the law of conservation of mass when we did the counting of atoms. But we're going to learn about all the parts of writing a chemical equation. So key terms. The first one you need to know is chemical equation, oddly enough. A chemical equation is an expression using symbols or formulas to represent what happens during a chemical reaction. So it's basically a way to write down what's going on. And you've seen me do this on labs already. The law of conservation of mass we learned about the other day when you did the onions fusible alloy and you melted it down and then put it back together. But it states that matter cannot be created or destroyed. You have to conserve mass. It can't go anywhere. So what this means for you is you must have the same number of each kind of atom on the left and the right of an equation, counting the atoms. A reactant is a substance which undergoes a chemical change. So it's everything to the left of the arrow. So everything on the left-hand side are the reactants. They're what reacts. And then on the right-hand side, you're going to have the products. So products are substances formed as a result of a chemical change. And I always think this one is pretty easy to remember because like in math, if 2 times 4 is 8, 8's the product, and it's still on the right-hand side. So the product is what you get out, the product of the chemical reaction. So again, everything to the right of the arrow. So reactants on the left, products on the right. The arrow is the key term. Good day for the arrow. The arrow in a chemical reaction means produces. So if I have hydrogen and oxygen on the left, hydrogen and oxygen together produce water on the right, or H2O, whatever it's going to be. It also separates the reactants from the products. So left of the arrow, reactants, right of the arrow, products. The coefficient. A coefficient is the number in front of an element or compound. It shows you how many of the element or compound are involved in the reaction. You can change this number so that you can balance the equation. Okay, and we looked at that, let's see, at the bottom of your precipitate lab where we put those 2's in so that it would be balanced, so that it would all work out. And lastly, the subscript, which is the number placed below and after an element in a compound. This number cannot be changed as it changes the identity of the compound. And we looked at this when we made compounds with our periodic table. If you're joining lithium, which tends to give away 1 electron, with nitrogen, which steals 3, you need 3 lithiums to make that nitrogen happy. So you'd have Li, and then the little 3, and then the N for nitrogen. I could have done a better job with this in more pictures, but here we go. So in this picture here, this 2 right here would be your coefficient. So you'd have to have 2 H2s. This 2 is your subscript. Whoa, I didn't realize we'd get that close. And like that 2 is a subscript as well to make 2 H2Os. Whoops, I went too far. Okay, so 2 H2s and 1 O2 would yield 2 H2Os. You need these 2's here to balance it. If you didn't have them, you'd have 2 H's and 2 O's on the left and 2 H's and only 1 O on the right. So you know you need 2 O's. So you have this, oh, I'm sorry. Yeah, 2 H's and 2 O's. Yeah, 2 H's and only 1 O. So you know you need this 2 here. So now you have 2 O's on the right and 4 H's. Now you're at 2 and 2's, so you have to add this 2, so you have 4. And that's what we're going to practice doing in class tomorrow. It's basically counting, checking your work, adding a coefficient, counting again, checking your work. So all you really need to do for this unit is be good at counting. So it should be a fairly straightforward unit for you guys. And that is about it.